Okay, this is the third section in chapter 3, and we're breaking the periodic table down into kind of basically two groups. The huge group of metals, and then the next section is going to cover non-metals and metalloids. And metals get their own section just because there's a huge variety of them on the periodic table, but there's still a lot of similarities between the metals as well. And so we're just going to kind of talk about major groups of metals and kind of their properties and some of the things that they do, because there's definitely some families in the periodic table that have some very specific properties that kind of set them apart from the rest of the metals. Okay, but in general, we'll talk about metals in general because we know what a metal is. We're familiar with what a metal is, but some physical properties, so some things we know about metals physically, so things we can see, we can just by looking or by doing simple things figure out if it's metal. So for instance, they are malleable, which means that they're going to be able to be like hammered into sheets. Most of them you can have sheets of the metal. They are ductile, which means they can be made into wires. Most wires, if not all wires, are made of metal, some sort of metal depending on what type of wire you're using. They are conductive, which means they allow electricity to flow through them, and most of them are shiny as well. So things that we can talk about metals as far as some very specific things we can look at and test very easily. Chemical properties, these are things that we can't necessarily see, but we know about metals. So for instance, they react by losing electrons. They corrode with oxygen. They have rust. A lot of them will rust because of that, because that's what rust is oxidation. So those are some kind of basic properties of chemical properties of metals. There's many more, but those we're going to talk about individually in each of the groups. So those are your general chemical properties of metals. Okay, some more stuff about metals as far as general stuff. Reactivity. Some metals are very reactive, some are not. So that's why we kind of talk about them separately at points. Reactive metals goes down, so it decreases. So the highest reactive metals are going to be found on the very left side of the periodic table, and then it goes down as you go from left to right. So my most reactive metals are going to be found in what we call family 1, or the one that's on the far left of the periodic table. Excuse me. So it starts at the top with lithium, then sodium, potassium, rubidium, cesium, francium. These are all extremely reactive metals. They're really never found uncombined in nature. What I mean by that is I don't find just plain old potassium sitting around by itself anywhere in nature. It's going to be in a compound all the time. The reason for this is because as soon as it is exposed to air or liquid, whatever it's exposed to, it's going to react violently and it's going to create a compound. Because that's what they do. They're constantly looking for something to make them happy. And what they're doing is they're looking to give up the one electron that they have in their outside shell. We talked about electrons in a couple of sections ago, but electrons are the things that kind of cause bonding. I didn't really mention that, but when bonds are created between different elements, it's done through the electrons. And because these are found in group 1, which is the far left side there, we can talk about that they only have one electron to bond with. So they have one electron in their outside shell that causes them to bond. And so they lose that one electron very easily, and because of that they bond with basically anything that will accept that electron. So here are some things that contain these particular metals, and they're highly reactive. So potassium, here's a picture of potassium in its elemental form. Notice it's in a liquid. A lot of times if you're going to get these things from like a chemical supply place, they will be given to you in a liquid, inside a liquid that is going to be protecting them from reacting with things. Bananas have potassium in them. Bananas are not explosive, but they have potassium in them. That is a alkali metal. And then fireworks can also contain potassium as well, which is one of the things that you can burn there that causes the different colors in those reactions when the fireworks are lit off. So again, very, very reactive metals found on the very far left side. It's called group 1, and they're very, very reactive. Okay, now this is group 2. Group 2 is also very reactive, although not as reactive as the ones in group 1, because they have 2 valence electrons. So on the group 2, so last one we talked about was group 1, these are group 2, which means that they give up 2 electrons. So they are found in group 2, they react by losing those 2 electrons, and because they have 2, they still want to give up those electrons very easily, so they're going to react very quickly with anything that they come in contact with. The magic number that electrons want to be at is what we call 8. 8 is that magic number. So if they have 8 valence electrons, or 8 of those electrons in their outer shell, then they're happy. But otherwise they want to get to 8. And so losing 2 is very easy to do rather than gaining 6. So if something wants to take 2 of electrons from you, or 1, if you're an alkali metal, you're going to get those up very easily, which is why they're so reactive. They're good conductors, though, so that's another one of the things we can talk about. So here is a list of alkali, they're called alkaline earth metals, which are very similar as far as, like, we talk about alkali, these are alkaline earth. They're beryllium, magnesium, calcium, strontium, barium, and rubidium. Anyway, calcium is the one that you probably would recognize in there. Calcium is in a lot of things, cheese, milk, things like that. It helps your bones be strong. Your bones actually need calcium to make them stronger. They're found right here in the periodic table. So here's my second family here. And then the ones alkali metals. I don't know if I pointed out, but those would be the ones right next to my group 1. Okay, then we have a whole big group here, as you can see, kind of highlighted in blue. These metals all go together, and they are called the transition metals. So they basically transition from the very reactive side over to this side of the periodic table, which is not mostly kind of focused on the nonmetals and the metalloids. So they kind of transition from one end to the other. And within this group, the reason why they're kind of all clumped together is because they have a lot of the same basic properties. For instance, a lot of them are used for different things, like gold, silver, are used for jewelry. Copper is used a lot for wire, also used in coins. There's a lot of them in there, but a lot of them have similar properties. They're not super reactive. They are very useful to people. They are found in a lot of different things. So they're very familiar. They're hard, they're shiny, they're good conductors, just in general. Here, this is like a little paint palette here, which contains these different compounds like cadmium and zinc and chromium and cobalt. All of those are found in maybe these different paints that they're showing you here. And so they can also be put into dyes for paints and things like that as well. Anyway, so they're useful, very useful materials, and they're kind of all found together because, or they kind of all go together and they're separated into different families, so kind of their own family themselves, just because of their similar properties. Okay, so these are just a couple pictures here. I'm going to talk about them in a little bit more detail in the next one, but metals in mixed groups versus the lanthanides, which falls down below here. We talked about the lanthanides, but they fall down below. So they're taken out kind of right in here and they put down below here because we want to save space. So otherwise the periodic table is very wide, hard to fit on a couple different pages. So they're put down below just for that reason alone. And then we've got our metals in our mixed groups here. So these are going to be found in some different groups that are not part of transition metals. They're not alkali metals. They're not alkaline earth metals. But they're still found over on kind of the right side as we're heading into the metalloids and the, of course, nonmetals. There are some kind of known ones. There's lead and there's tin. Those are 2 metals that aren't found in the transition metals but are found over here. Very similar as far as how they react. Some of them are a little bit more reactive than others. As they fall into these groups over here, a little bit more reactive than this kind of stuff right here. Then we've got our lanthanides, which would fall below here. One of the neodymium is used to manufacture speakers inside stereo headphones, so that is one kind of use for something that falls down here. Again, it's a metal, and so they'd be similar as far as some of their physical properties. Okay, so ornithodites, as I was saying before, are used in alloys, which are mixtures of metals and other elements. So it's kind of a mix of metals that group down there. So if you find a lot of those metals are not going to be used necessarily alone, they'll be used with something else, put into like a compound with that creates a more useful substance because of that. Actinides that are heavier than uranium were all created artificially in laboratories. So again, this is going to be your actinides, which are the ones that fall down here. And so the actinides, some of them are found like naturally in nature, but a lot of them are not. So uranium is going to be found in nature, but pretty much everything heavier than that was going to be created in laboratories. Some of the stuff that's created in laboratories is useful. So they have created some that are useful, but some that really have no use at all because they're very, once you kind of create them, they start to break down. So there are some useful ones that were created in laboratories, but not necessarily a lot of those. Those are your actinides or lactanides that are both groups of metals that kind of fall down below the periodic table. Okay, so most of the synthetic elements that are being created are going to form a metals group just by the way that they're created. So how do we make synthetic elements? Well, we use these things called particle accelerators, and what they do is they force nuclei to move at very high speed. So basically the neutrons and the protons to move very, very quickly, so quickly that they can crash into each other, and if they have enough force between them, or among them, or against them, they're going to form a single nucleus. And so that single nucleus is going to create basically a new element. So if you have enough protons that you're able to kind of force together, neutrons, into that single nucleus, you can create a new element. So these nuclear particles are kind of forced together. Once you get the protons and the neutrons in the nucleus, the electrons should follow because of the charges that the protons have. And then you have yourself a brand new element. Now that element probably won't be very useful because a lot of times these ones that are being created by particle accelerators begin to break down immediately, start to kind of break apart, and so they're not necessarily useful. But they can create them, so they can create them in laboratories. There are a couple. This americium 241 is used in smoke detectors. So here's a synthetic element that was created that has use to it as well. So there's not a lot, but there are some useful ones. Okay, so this is the end of section 3 on metals. There'll be homework for this one posted on Particle Learning, which is the part of that April, like 16th, 17th, hand-in date. And it can be printed off. It was in a packet that could have been picked up, or you can just do it off of Particle Learning. You can just write on a sheet of paper and turn it in that way as well. Enjoy!